Hello dear students, I am Meghamala, working assistant professor from EC Department, Institute of Aeronautical Engineering. And today I am going to talk about design constraints and environmental disturbances part 2. So here, in the previous section, we have discussed about different types of constraints and also the environmental disturbances which occur when we are not able to get the proper output. And also we have discussed about different types of constraints. The constraints are nothing but the input-output constraints, and few constraints depends upon the connectivity, few constraints depends upon the area and the locality. Okay, and now in this part 2, we will learn some more about the different types of constraints and their specifications and the working principles in terms of Verilog. Okay, so coming to the constraints, so useful stimulus is more than just random values or variables. There are relationships between the variables. So here, when it comes to the constraints, as I said we have different types of constraints based on the area, based on the pin configuration, based on the connectivity. Okay, and so for each and every constraint, there are set of variables. Okay, so there are set of variables will be given for each and every different constraints, and then otherwise it may take too long to generate interesting stimulus values, or the stimulus might contain illegal values. So here, being a designer, we have to set some variables. Okay, so for each and every constraint that are occurring in the designing process, we as a designer must set the variables. Otherwise, the variables which are not set by the designers are to be called as the illegal variables. So such that this sentence is saying that it may take too long to generate interesting stimulus values, or the stimulus might contain illegal values. So, being a designer, at the moment we must aware of the variables giving to that pertaining constraints. Okay, then you define these interactions in system Verilog using constraint block that contain one or more constraint expressions. So, we know that Verilog is a language. Okay, Verilog is a hardware description language where in this Verilog we have different libraries. Okay, so these different libraries contains different variables and set of variables, group of constraints. So as we discussed in the previous sections regarding the library, the gate under the gate level modeling, in the gate level modeling technique, the gate primitives can be observed from the library. So as well, the constraints also we can get the variables, or else we can get these constraints from the Verilog. Okay, so that from the system Verilog we can able to get the constraints, and that constraints we get it from the constraint blocks. So from the constraint block, we can acquire one or more constraints. Okay, one or more constraint expressions. So as we have in the gate primitive library, so similar fashion we can have the constraints in the constraint block as well in the system variable or a system Verilog. Then system Verilog chooses random variables or values so that the expressions are true. So what the system variable does is, the system Verilog, it chooses the variables, or else it chooses the values. Randomly it chooses the values until and unless we get the expression true. It chooses the values or else the variables from the library system Verilog from the constraint block. Then at least one variable in each expression should be random, either ran or ranc. So here we are representing the variables. So here this sentence is telling that at least one variable in each expression should be random. So either if you are considering 10 variables, out of 10 variables, at least one variable should be picked up randomly. Okay, so we can given such a variable name as ran or ranc. So at least one variable in the each expressions can be randomly taken and given either ran or ranc. The name can be given to that particular variable as ran or ranc. Then the following class fails when randomized unless age happens to be in the right range. So what happens here? We see when we are considering, or else when the name given to such variables randomly, if randomly some variables are picked up from the constraint block and given the name, if we are giving to that particular variables, what happens is only in few cases the randomization gets failed. Okay, only in few cases it gets fails when randomized and in the right range. So if we are not giving the names, or else we are not able to specify the names to the variables randomly, if you are picking some variables from the constraint block, and if you are not able to give the names to that particular variables, okay, so in this scenario what happens is sometimes we can fail. Okay, so sometimes we can fail, we may not go in a right proper manner. So we have to be very careful when we are giving some names to the variables from which we are getting from the constraint blocks. And then the solution is to add the modifier rand or ranc before age. So here when we are missing, or else when we are failing into this particular cases, how can we resolve this? There is a problem. There is a solution for this problem. The solution is we can add. Okay, the solution is to add the modifier rand or ranc. So we can solve this solve this kind of problem. How is by using a word like modifier rand or ranc before the age. So here in this particular, why am I calling age is in order to understand very keenly. Here we have an example. So this is an example. This example talks about the class child and bit 31:0 age. Okay, so here we are mentioning the age 31:0 and then error D should be rand or ranc. So here as a designer, what I will do is I have to give some name to the particular variable, right? So I can be given in terms of rand or ranc. So here the constraint C teenager. See, has the child is in the age between 31:0 range. Now the constraint is C teenager. So here age, it could be more than 12 or else less than 20. Okay, but here what we are observing here, the range is going between 31:0. That means totally 32 years, isn't it? But what happens is the randomly the name or else the name which we are giving is between the age greater than 12, or else another variable is age less than 20. But nowhere we have given this age. So what happens? This will got fail. So in such cases, what we can do is we can solve the problem by using modify rand or ranc. Okay, instead of rand, we can introduce modify rand or ranc. So here the randomize, this is nothing but the randomization. The randomize function tries to assign new values to random variables and to make sure all constraints are satisfied. So here there is not specific, right? The age given here as per the code, the age given here is not specific. Unless and until we are giving the name of the variable, we are not able to know the specific age. So in these cases, what happens is most of the time, if we are arising such kind of things, means we will be failing. We see the failures, right? So in order to overcome that failures, what this randomizations will help us. So randomization, it tries to assign new values. Okay, so being a designer, I can make use of randomization where I can give new values to the random variables. Okay, these are the random variables, new values to the random variables to make sure that all the constraints are satisfied. So in order to go as per the question being asked, we can make use of the randomization well. Then in the example, this is an example. Since there are no random variables, so here we don't have any random variables. So randomization just check the value of son to see if it is in the bounds specified by the constraints teenager. So here in this particular example, we don't have any random variables. But what we can all see is here they just mention the age. One age is above 20 above 12 and the other age is less than 20. Okay, so here we can see only if it is bound specified by the constraint C teenager. This constraint C is only specifying the age. Okay, the age, it could be of greater than 12 or less than 20. Unless a variable happen to fall the range 13:19, randomized fails. So here we see only 31 0, but nowhere we are seeing 19 like that. But here, see here, randomly what am I doing is, being a designer, I'm just picking up the numbers. So what the numbers, the range, the age of the child, the range, the average age of the child, I'm picking it 13:19. So here randomly nowhere I've mentioned. So what happens is my randomization gets failed, isn't it? So while you can use constraint to check that a random variable has a valid value, use an assert or if statement is inserted. So here we are seeing only 31 0, greater than 12 and less than 20. So this is what we have, this is what we observed, right? We observed, but here nowhere we have seen 13:19. So this is 13:19 is nothing but the random variables. Randomly a designer is picking the variables and he is telling that the son's age, it could be around 13 to 19 years old. But if see this kind of numbers we are not seen anywhere. So what happens here, randomly we have picked some values and that values are not matching to the given questions, right? So what happens is randomization gets failed. So in order to overcome these randomizations, being a designer, what I can do is I can give simply a age which is nearer to the specified range. So here the value we can to check, in order to check the constraint is working or not, we can have a non-random variable. Okay, randomly not just to avoid this, we can go for a non-random variables which has a valid value. Okay, non-random variables are around somewhere 12. That means here around 12 or 18 like that. Non-random variables which has a value and they can use as asserted if statement instead. So here in this particular example, we did not use any if statement, if conditional statements are nowhere used. But in order to avoid this randomization, we can make use of the non-random variables. We can take the help of non-random variables or values so that these non-random variables can be specified only if statement is considered. Okay, so that is how we can change. Then the following example shows a simple case with random variables and constants. So this examples will tells about the random variables and the as well as the constants. So let's learn class stem. Okay, constant bit 31:0. Okay, then conjunction addition adder, conjunction adder 42. Type different number, read write control. Ran C, see here the random bits ran C and ran. Rand and ran C are the name given to the particular variables, and ran C stem e kind enumerated value variable. Rand bit is 31:0. Okay, so these are the data, and then bit conjunction test. And now constraint C stem. So here what we can see, less than 1000 and more than 100. So here the last given priority or as a last given number, it would be around 1000, and the first given would be around 0. So here if you observe, we are making use of if condition, if statement. Why? Because here the randomization gets fails. Why the randomization get failed? Why? Because whatever the variables we are giving randomly, it's not matching to the given problem. So if it's not matching, what happens is we can give voluntarily the other numbers, non-random values. Okay, the non-random values can be given. If you are giving the non-random values, then that particular values can be observed only with the help of if statement. Okay, if conditional statement. So here the randomization got failed. So in order to overcome this, I am using non-random values. Okay, so as I'm using non-random values, I can only go with if statements. So if congestion test data inside congestion address 100 and congestion address plus 100, minus 100 and plus 100, and congestion address else. Okay, and then else, if this is not the case, else what is the case? Else inside 0, 2 is to 10, 100 is to 1 and 7, end case. So this is how I can write the program, or else this is what how can decode the program when I'm going to get any fails. This is nothing but just to overcome the failures. We can make use of the non-random variables, and that non-random variables can be implemented only with the help of if condition statements. Okay, and then the example showed a constraint block with several expressions. So here this is a constraint block. We have these several expressions, right? So here if you see, we have several expressions, double colon, double equals to, okay, and then colon, and then here concatenation of the things, concatenating. Okay, so these are nothing but the several expressions. We know double equals to, colon, and flower braces. These are the expressions. So the first two control the values for the len variable. As you see, a variable can be used in multiple expressions. So here in the previous expression, you can see a variable can be used with multiple expressions. So here if you observe, we are using this flower braces, we are using the colon, and we are using the number as well, and the underscore as well, isn't it? These are the expressions, underscore, flower braces, colon, colon here. Okay, so what the constraint, regarding the constraint, we can say that we can use multiple expressions. The variables can be used multiple expressions and multiple times. So there can be maximum, or if maximum of only one relational operator in an expression. So in the expression, there can be only one relational operator. So what are the relational operators? Less than, greater than, equals to, right? Less than or equals to, double equals to, greater than equals to, or greater than. So these are the relational operations. So in the expression, instead of saying multiple times, we can see, or else there can be maximum only one relational operators could be observed. Only one relation operators is being seen in the expressions. So here, this is a below sample incorrectly tries to generate three variables in a fixed order. So here three variables in a fixed order we are going to generate. Class order, rand bit is 7:0, that is totally L bit. Okay, L, that is low, medium and high. Okay, the category here is mentioned as low, medium and high, order wise. So constraint bad, low means from low to medium to high. So obviously low less than medium, medium is less than high. This is a scenario. Okay, this is which is nothing but the right. Then end class. So here this expression is talking about the constraints, how we are overcoming the expressions. Regarding the expressions, we are saying that only one relational expressions can be used, or else only one relation expression can be observed. So here, as I said you, only one, that is less than. If not, only greater than we can consider. If not, only equals to. If not, less than equals to. If not, greater than equals to. So only one, any one relational operation can be considered, but not the multiple one. Then the result goes like this. As I said you, we have three ranges, right? Order is low, medium and high. So low 20, medium is 24 and high is obviously 164. And then low is 114, medium is 39 and high is 189. So if you observe, there is a comparison, right? So what is the comparison? Low values are obviously lesser than the medium values. So low values are lesser than the medium values, and medium values are lesser than the high values. So here in the result, if you observe, all the low values are lesser than the high values, because in the code we have given only one relational operation, that is low less than, medium less than, high. Then coming to the expressions, simple expressions. So here the simple expressions is example shows the results which are not what was intended. But here the constraint bad in sample is broken down into multiple binary relational expressions going from left to right. So here if you observe, we can see multiple times the less than relational operation is observed more than 2 times. 3 times we have observed, right? Low, less than, medium, less than, high. So more than 1 times it is repeated. So that's the reason the sample is broken down into multiple binary relation operators. So 1 time if you are considering, it is fine. Low is less than medium. But here what we have seen, low is less than, medium is less than, high. So multiple times the relational operation is being occurred. So we can say that the sample, the given example can be broken down because the multiple times the relational operator is repeated. Then the expression low, less than, medium is evaluated, which gives 0 or 1. Obviously, we have low, less than, medium, less than, high. So from this expression, first what we do is we can go with this low, less than, medium. Okay, so this is first evaluated, and then it goes with medium, less than, high. The second it will be evaluated. Then the highest constraint to be greater than the result. Obviously here as per the expression we are observed that high is the which goes a high value. Okay, so later on after comparing the low and medium, the whatever the result that is fine when you compare low and medium, that result will be again compared with the high value. So obviously high is will be greater than the number which is obtained from the low and medium. That number will be obviously less than the higher. Then the variable low and medium are randomized but not constrained. So here we can say that these two are randomized. Okay, so that means what, here we can give the numbers as per the category. Okay, as per the class we can give the numbers. Low values, obviously less number will be assigned. Medium values, which is a little more than the less number. So here the randomizations can be observed. Then here see for example class order, rand bit. Rand is a keyword which is given for the constraints in order to know the randomization. Rand bit 15:0. Again here we are seeing the order low, medium and high. And now constraint good. If it is good means low, less than, medium. Okay, only use binary constraints. So if it is good, low, less than, medium, and this is one constraint, and medium, less than, high. This is the other constraint and the end class. So here what happens is the relational operation is not repeated. As we see in the previous example, we have seen that low, less than, medium, less than, high. So here if you observe, the relational operation is repeated twice, but where it shouldn't repeat like that. Only one time the relational operator can be repeated in the expression. Okay, so but here in this expression we see the relational operation can be observed only one time when you compare between the two constraints, that is low to medium one time and medium to low, high one time. So this is okay, this is to be considered. So these are the simple expressions, and the most common mistakes with constraints is trying to make an assignment in a constraint block, but it can only contain expressions. So here the most common mistake that we can do as a designer with the constraints, the most common mistake is trying to make an assignment in a constraint block, but it can only contain expressions. So the assignment, whatever is observed from the constraint block, okay, the constraint block, it contains the expression itself. So here, but can only contain expressions. It contains only the expression, and that expression is consists of different types of operations. As in the previous example, we have seen the expression consists of the relational operators. So likewise, with the help of logical operators also we can observe the expression. And then instead use the equivalence operator to set a random variable to a value. So here what he is saying, either we can go with the less than operator, okay, and or else we can go for the equivalence operator. So equivalence operator is to set a random variable to a value. So here, instead of less than variable, we can also go with the equivalence operator. And if not equivalence operator, we can also go with the greater than operator, relational operator. Either way we can consider either greater than, less than or equivalence operator. So here in the example, we see the length is double equals to 42. Okay, so you can build complex relationships between one or more random variables, like how len double equals to header. Okay, this is one operator, dot adder underscore mode into 4 plus payload dot size into the braces. So here you can observe complex relationships between one or more random variables. So we can also build not only a simple way, or as using one relational operator or as one equivalence operator, but also we can go with the complex relationships as well. So here this is a complex relationships where you observe the relational operation equivalence operator, where the dot product and underscore and multiplication and addition. Okay, so these are the terms, or else these are the different categories, like where the relationships, these help us to tell the relationships between all these variables, random variables. So not only we can use only one relation operator in the given expressions, but also we can make use of many complex relationships between the variables. So this is nothing but the equivalence expressions. Using equivalence expressions, this is how we can write the example. And coming to the conditional constraints. And what is this conditional constraints? Normally, all constraints expressions are active in a block. So in the block, if you are considering any constraints, input output constraints, or else area or the locality constraints, all the constraints will be active in the particular blocks that you are executing. Okay, all constraints expressions are active in a block. Then, for example, a bus supports by byte. Okay, so bus is nothing but it contains of numerous wires. What is this bus indicates? Bus says that all the wires are connecting in a single strap. Okay, where you won't see any overlap, or you won't see any wires seen clumsy inside the bus. All the wires are arranged in a same fashion. So here a bus supports, what it supports? Byte. You know what is a byte? 1 bit is equals to 8 bytes, right? And word is equals to 1 bit is equals to 1 word is equals to 16 bytes, right? So byte, word and long word reads, but only long word writes. So here example, this is a conditional constraints we are talking about. In the conditional constraints, we are considering a bus. So what does this bus do? It has a wires, or else it can help us to get the byte. Okay, it's supposed to get the byte, word and long word. So this bus will what it does is it just reads out, but only long word writes. So it reads long word and byte, but also it can also read long word writes. So read or write, isn't it? So it can read, write long word. Here also it can read long word. Whereas here in the read option, it can read byte, it can read word as well. It can read word, byte and long word, and also along with this, it can write long word as well. And then system Verilog supports two implication operators and if else. So here under conditional constraints, okay, under conditional constraints, the constraint block or else the system Verilog, what it does is it provides two implication operators. Okay, two implication operators, armark and if else. These are the two implication operators. When you are choosing from a list of expressions such as enumerated type, the implication operator is nothing but the moving forward lets you create a case like block. So here when you are choosing some expressions, from the list of expressions if you are choosing, you can see the enumerated type, such as like in the list of the operators, you can see the enumerated type operators or else implication operators, and as well the case-like block operators. The parentheses around the expressions are not required but do make the code easier to read. So here, when you are writing some code, okay, for each and every module you have to write a code, right? So in the code, it's not needed. Sometimes the parentheses around the expressions are not required. So sometimes the parentheses are required, but sometimes the parentheses are not required. So why? Because we can, in order to make the code easier, there is no need to write the parentheses. This is what he's saying. And now see here, this is a conditional constraints example. In this example, class bus, okay, bus stop or its bus, constraint C in and IO space mode, address 31, okay, 10 bits of binary. That's it. So here if you observe, we are mentioning the space mode, okay, we are mentioning the space and how much of space it is, 31 address bits of space, and also this bus contains IO input output space mode, okay, bus contains input output space mode along with the 31 bits of address space. And then if you have a true false expression, if the if else operator may be better. So here sometimes what happens is we have to from the code we can able to know whether the given expression is true or false. So if you have a chance to get to know what is true or false, we can make use with the help of if else. Okay, with the help of if else conditional constraint, we can able to know easier which one is the true or false. So if else plays a vital role in order to know whether the given code is true or false. Then the constraint block with if else operator. So as I said you, the if else conditional block operators, every operators are indulged in this constraint block. So class bus, and this class contains the constraint C, okay, read and write, constraint C, read and write. Then if operator double equals to read. So here the relational operator, if operator is double equals to read, length of that particular word is length inside byte is equals to, okay, byte is equals to length of the word, and then else if not, length is equals to length of the word. So what it is saying, length inside the length of the word is byte. If not, length is equals to length of the word. Okay, so here as I said you, we can make use of, in order to know if it is true, this is obviously true, and if you want to know if you are getting that it is a false, then make sure that you are using this if else operator. So this if else conditional operator will help us to know whether the given code or else whether the given expression is true or false. Then in constraint block, you use curly braces. So these are the curly braces to group multiple expressions. So obviously what is this curly braces contains? It contains multiple expressions. The begin and keywords are for procedural code. So here in this procedural code, obviously we have to write begin and end. These are the very prominent keywords. So module, it should start and it should end with end module. And if it is starting with begin, it should start with end. Okay. So now coming to the bidirectional constraints. So till now we have discussed about the conditional constraints, if else, and previously we have discussed about the equivalence expressions, and also we have simple expressions. Okay, simple expressions where it contains the logical operators, and in the equivalence expressions we can make use of the equivalence expression, equivalence. And now conditional expressions says that if else, by using the if else condition statement, we can able to get to know the expression whether it is true or false. And now coming to the bidirectional constraints. So what is this bidirectional constraint mean? So by now you may have realized that constraint blocks are not procedural code executing from top to bottom. So you have to remember one thing, as we are in module 5 till module 4, we are writing the code in terms of behavioral modeling, using with the help of procedural assignments, and then using the assignment, non-blocking assignments and blocking assignments. And now we are in fifth module. We are concentrating about the machines, and in this machines we are concentrating more about the different constraints, designing part, okay, designing part, environmental constraints, and all different types of constraints. In this constraints, we need to realize that the constraint blocks are not procedural code. What is this procedural code? Procedural code is nothing but this code will start from the beginning and it should end up. Okay, initial, begin and end module. So as I said you, the constraints are not the procedural assignments, or these are not the procedural code, where the procedural code they executes from top to bottom, right? But these are the these constraints, bidirectional constraint, the constraint blocks are not the procedural code, where there's no need to execute the code from the top to bottom. They are declarative codes, all active at the same time. So as these are not the procedural codes, what are we calling them? If they are not procedural, we are calling them, or else we are saying that the bidirectional constraint blocks, these constraint blocks are nothing but they are the declarative codes. Okay, declarative codes, all active at the same time. Why we are saying it's a declarative codes? Why? Because in the constraint blocks we can make use of the operators, different types of operators, relational operators, logic operators, and concatenation, and as well the bitwise operators. So we are saying that these are the declarative codes. The conditional constraint blocks are the declaration codes, and these codes are active in all the time, same time. Then if you constrain a variable with the inside operator, okay, if you constrain the variable with the inside operator with the set 10:50 and have another expression that contains the variable to be greater than 20. Okay, so here he is giving some, or else he is explaining some questions with some variables. So what is he doing? Inside the operator, okay, inside the operator we get to know like we have totally 60 variables, and other expression contains, or else the other expression that constrains variable which is to be greater than 20. And now here we have 60 and other constraints we have 20. So in these two cases, what sort of declarative code that I can make use is using the bitwise operator, relational operator, 60 greater than 20. Okay, so in other cases, or else if you consider other example, if you consider an example, 60 is a bit, that is 10:50, or else 30:30. 30:30 is a set, okay, which is to be less than 20, which is to be less than 90. Okay, so here what I did is I've changed the values. Okay, I have a chance to change the values as well, because being a designer I have the right to change the variables in order to overcome the randomization. So being a designer, what I'm doing is I'm just considering a set with 30:30, that is totally 60 bits, and then what am I doing is expressions at the variable I'm considering which is to be less than 90. Okay, greater than 20, this is what we have considered in the previous example, and now I'm considering it must be less than 90. So here totally how many bits I have? 60 bits. And what am I telling? The expression will be less than 90. So what sort of code? This is a declarative code where I'm declaring that the given expression is less than 90. Okay, so this is the expression that I have used. And in case sometimes we can use equivalence operator as well. So system Verilog, what it does is it solves both constraints simultaneously and only chooses value between 21 and 50. So here what they're saying is the system Verilog, it solves both the constraints. Okay, so this constraint, the system Verilog has a capability that it can solve multiple constraints. Okay, constraints, and also they can choose values. The constraints or else the variables can be chosen between 21 and 50. So here from 21, which should be less than 20, right? But here being a designer, I can choose the values which should be 21 to 50. So if I'm choosing 21 to 50, what happens? I can make use of sometimes less than, sometimes equals to as well. If it is 50 is equals to 50, equivalence operator is met. If it is 42 is equals to 42 less than 50, obviously less than operator is been considered. So this is what a system Verilog will help us to, it can solve both the constraints simultaneously. And then the system Verilog constraints are bidirectional. So here our main, the topic is bidirectional constraint. So here the system Verilog is a bidirectional, which means that the constraints on all random variables are solved concurrently. So here why we are calling this system variables as the bidirectional constraints. Why? Because the execution of all the random variables, whatever we have picked in order to achieve the proper output, whatever the variables are picked by the designer, we are saying that the execution of that particular variables can be solved concurrently. Simultaneously, that can be solved. So that's the reason we are calling these are the bidirectional. The constraints are bidirectional. And then adding or removing a constraint on any one variable affects the value chosen for all variables that are related directly or indirectly. So here we have a what do we say? We have a chance, or else we are given to consider the variables. Okay, randomly we are given to consider the variables. If it is high number in between the number, if we have a chance to consider the variables. But if you are adding the variables to the obtained variables, if you are adding or removing, okay, if you are adding or removing any one variable from the constraint block, what happens is there is a chance of losing. There's a chance of all the variables related to directly or indirectly. So it affects the value chosen for all variables that are affected. So if you are adding some value to the given constraint block, in the constraint block, to the constraint block, if you are adding or else if you are removing any sort of values, then obviously it gives, okay, it gives a negative impact for the constraint block. So we have to be very careful that only in the given values, or only in the given a bunch of variables we can able to pick the random variables. But if you are adding or removing any sort of variables, then it is going to be it is going to reflect a negative shade for all the given expressions directly or indirectly. Directly we can affect the expression, or indirectly we are supposing to affect the variables. And now consider the constraint in sample. So if this is a sample that we are considering, let's look into it. Rand logic 15:0 RST. Constraint is C bidirectional. Now we are talking about bidirectional, right? So bidirectional, S double equals to relational operator, T less than 30, S less than 25. Okay, this is what the code in this particular sample. We are given variables, okay, numbers, values to different constraints. So now we will see the system variable solver look at all four constraints simultaneously. So what happens here? The execution or the execution of the constraint block. The constraint block, whatever the values, the numbers, variables are considered from this constraint block, they are going to execute simultaneously, concurrently. How is S, T and S can be concurrently executed? The variable R has to be less than T. The variable R has to be less than T, which has to be less than 30. So here we are saying that S double equals to R, isn't it? So this variable R must be less than T. What is this T? T is nothing but 30. Okay. And then, however, R is also constrained to be equal to S. R is also constrained to be equal to S. Obviously, when S double equals to R, R double is equals to S, which is greater than 25. Which is greater than 25. Why? Because the S is greater than 25. So here we see that in this expression, we made use of only one single relational operator, okay, equals to, double equals to. So here S double equals to R, and that R must be less than T. That means what? S double equals to 15, which is less than 30. Okay, this is one can be achieved, one can be executed, and R double equals to S. What is S? S is nothing but 15, which is less than 30, and which is more than 25. Obviously, S is more than 25. So the execution will takes all these terms what random concurrently, simultaneously it will be done. Then, even though there is no direct constraints on the lower level of T, the constraint on S restricts the choices. So here what this sentence is talking about is, even though there is no direct constraints on the lower level of T. So the lower level of T, if there is no constraint under this lower level of T, the constraint on S restricts choices. So constraints on S restrict the choices. Yes, obviously. Why? Because here T is which is more than R. If T is more than R, what happens? The S must be less than T. That is what he is saying. There is no direct constraints on the lower level of T. The constraint on S restricts the choices. So it just give back the choices. It will not accept the values or variables that we are giving. It just restricts. And now valid constraints. So what are these valid constraints? A good randomization technique is to create several constraints to ensure the correctness of your random stimulus, known as valid constraints. So here the randomization, the good randomizations is to create, or else it can be achieved, several constraints. Okay, so in the randomization process we may go with the several constraints, several constraints to ensure the correctness of the random stimulus, known as constraint value. So in order to just to ensure the random stimulus, randomly the variables that you are considering, okay, that you are picking up, in order to ensure the random stimulus, we are saying that we can achieve a good randomization. So that is nothing but the valid constraints. So here in the example, a bus read, modify, write command might only be allowed for a long word data length. So here in the previous example, we have considered a bus. So here in this bus, as I said you, it can read, it can write. The bus can read the long word, and it can write the long word as well. And the second thing is, the bus can read byte and word. The bus can read byte and word, but it cannot write byte and it cannot write the word. So here in this example, a bus read, modify, write. So three commands, read, modify and write, allowed for a long word data length. So the read, modify and write, read, modify, write is considered only for the long word data length. Only for the long word data length, the read, modify, write is considered. So here we'll see class transactions, rand, numbers, byte, word, okay, length of the word, quarters word, length, and then random variable, e number, read, write, okay, intro, and RMW OPC. So here if you see, these are just the initializations of the variables, random variables. So different variables, different values. There is some byte, word, long, long word, length of the word and keyword. And then now we will see the constraints regarding the valid. So constraint valid is RMW, low, read, write. Why? Because here just to ensure, okay, we are just making sure that the random stimulus, whatever we have considered, is just to overcome the randomization. We have just considered RLW and RMW. Okay, so OPC is nothing but RMW. OPC is RMW, which is This is a operator. What sort of operator it is? It is also a random operator where the length is LWRD. So here the length is LWRD, OPC is RMW. So these particular variables or this particular random variables, what am I doing is we are just omitting. Why? Because randomization, in order to achieve the randomization, what happens is only this word and keyword and this is sufficient. So this is what it says. A good randomization techniques is achieved, or else technique is to create several constraints to ensure the correctness of your random stimuli. So in order to ensure the correctness of this random variables, whatever we are taking or else whatever we are giving, in order to ensure the random stimulus is nothing but the valid constraint. So here the valid constraint is length of the word, and OPC, this is RMW. So by using the operator and end the class. So if you observe this operator, somewhere around here we have discussed this operator. So the operator, see, implication operators. So system Verilog supports two implication operators. Implies, this and if else. Okay, and if else. So these are nothing but the implication operators. So this implication operators, relational operators, logic operators, all these operators will help us to get to know, or else it will help us to give the random variables, or else pick the random variables from the constraint block. So in the so today's topic, we have discussed about different constraints. In yesterday's class itself, we have discussed about these different constraints, and today's class we are in depth discussed about what are the constraints and how can we represent the constraints by choosing the random variables. Okay, when we choose a random variables, the randomization is achieved, and because of the randomization, sometimes we may fail to observe the output. So in order to overcome those failures, what we are doing is we are just going for by considering different constraints. In order to achieve the randomizations, we are going to construct the different constraints. So those different constraints are in terms of simple expressions. Okay, in terms of expressions, that is equals to, less than, or greater than. Okay, and in the expression simple expressions, we have to remember one thing, that only one time the relation operation can be given, not for the multiple times. So here this is what the good example that we can consider, that only the relational operator less than is given only once when you are comparing with between the two cases, low to medium and medium to high. And then coming to the equivalence expressions also can make use of considering the random variables. Here we can see the complex relationships between two or more random variables can be achieved. So here if you see double equals to, underscore, and multiplication and addition. So here between random complex relationships can be considered between the one or more random variables. And then we are considered about the conditional statements. In the conditional statements, unless and until if you want to know whether the given code is true or false, then obviously we have to go with the if else statement. Okay, and also the system Verilog it supports the two implication operators. Implication operator, that is this one, towards, and the if else. So the good example that we have considered is bus. So in the bus we have seen one operation is meant for the reading, and also we can, so if it is meant for reading, and if not, it can also meant for writing. Okay, and then coming to the conditional constraints. Conditional constraints is same like that, using the if else operator. And also the important thing is these operators are, or as these codes are nothing but the declarative codes. Okay, so the declarative codes, these are not like the procedural constraints. The procedural constraints means when the execution, at the time of execution, we have to execute from the top to bottom. But whereas here, these are nothing but the declarative codes. There is no need to execute each and every part separately. Concurrently, simultaneously, all the different codes can be executed. And then we discussed about the bidirectional constraints. Bidirectional constraints are they can solve simultaneously all the given random variables, and also indirectly, if you're adding something or removing something from the constraint block, we have to be very careful that it's going to affect all the given expressions. Okay, and then coming to the bidirectional code is based upon the relational operations. Okay, based upon the relational operations, we can able to it's our choice that to go as per the given relational operators. And then coming to the valid constraints are just to know or else just to be aware or ensure about the random stimuli. Okay, in order to avoid a good randomization techniques, just we can ensure the correctness of the given expression. The random constraints can be help for us, where here we are using implication using the implication operator. This is how we can code the expression with respect to the class. And rand and ranc are the two constraint variables, or else the keywords that we can use. So this is all about today's class. I hope you all understand. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.